It's funny. Sometimes the most common things, the elements we think we totally know, have the most incredible and surprising stories. We're about to uncover the secret life of one of those elements, one that's hiding in plain sight all around us. So let's get into it. So let me start with a question for you. Think about the tech you use every single day, the medicine that saves lives, and even the life support systems way out in space. What single unseen element could possibly connect all of those things? It sounds impossible, right? But there is a common thread. You're actually holding one part of the answer in your hand right now, and the other part is literally orbiting our planet as we speak. This is an element that bridges the gap between our daily lives and the furthest reaches of human exploration. The answer is iodine. Yeah, that brown antiseptic stuff from the medicine cabinet. A little surprised? I think you should be. Because its story, from its discovery in seaweed over 200 years ago to its role in next-generation technology, is one of the most fascinating tales in all of science. All right, first up, let's look at iodine's most fundamental role, keeping us alive. And I'm not just talking about disinfecting a scrape. This is about basic human development and health on a massive global scale. And this number really shows you what's at stake here. According to global health estimates, a staggering 1.6 billion people are at risk of iodine deficiency. That is almost a fifth of the world's population lacking an element that is absolutely crucial for your body to function correctly. So, what happens when you don't get enough? Well, the consequences are severe. Goiter, which is this incredibly painful swelling of the thyroid gland, is the most visible sign. But honestly, the invisible damage is even worse. A slowed metabolism, stunted growth, and most tragically, it can lead to preventable mental retardation in children. For centuries, people knew something was going on, even if they didn't have the science to back it up. Way back in the 13th century, they used ash from sponges, which we now know are packed with iodine, to treat goiter. After it was officially discovered, the first tincture of iodine was used in 1820. And today, we use its unique ability to absorb X-rays in special contrast agents that let doctors see incredibly detailed images of our internal organs. But iodine's role goes way, way beyond medicine. It's also a hidden architect of our modern digital world. In fact, it's the key to the very screens we're all looking at right now. I want you to think of every single pixel on an LCD screen as a tiny, tiny light switch. Now, to turn that switch on and off to create the images you see, you need a very special key. And you guessed it, that key is made of iodine. So how in the world does that work? Well, your screen has these polarizing films that are coated with perfectly aligned iodine molecules. Think of them like microscopic gates for light. Okay, but it gets even wilder. We all think of plastics as insulators, right? They don't conduct electricity. But in a discovery that actually won the Nobel Prize, scientists found that iodine could flip a switch inside certain plastics, turning them into conductors of electricity. This whole process is called doping. And it's not about adding a lot, just a tiny, precise amount of an impurity, in this case iodine, to completely change a material's fundamental properties. It is the secret sauce behind some really amazing electronics. Here's a fantastic way to picture it. Imagine a plastic's electrons are like people jammed onto a packed train. Nobody can move. Doping with iodine is like a few people getting off at a stop, creating empty spaces or holes. All of a sudden, other electrons can shift around to fill those gaps. That movement is an electric current. It turns plastic into a conductor. So iodine is a lifesaver and a technologist, but it also has this surprising role as a protector in some of the most extreme environments you can possibly imagine. Take a look at these tiny beads. This is an iodine absorption resin. Up on the International Space Station, where every single drop of water has to be recycled, these beads are used to kill microbes and make sure the water is safe for astronauts to drink. It's so much easier and safer to transport than, say, chlorine gas. And this is where the story takes a really dramatic turn. The exact same technology, these very same beads, are also used in military gas masks to break down and neutralize some of the deadliest chemical weapons known to man, like VX gas. From providing safe drinking water in space to protecting soldiers on the ground, that is just incredible versatility. So, what's next for iodine? After more than 2 centuries, you'd think we'd have found all of its uses. But nope, scientists are really just getting started, and it's set to be a key building block of our future. Take a look at this. This is the crystal structure for what's called a perovskite solar cell. It's this revolutionary new technology that's both cheap to make and highly efficient. And as you can see, the purple spheres there, that's iodine. It's a critical part of the structure. Its unique atomic properties are what help the crystal absorb sunlight so effectively. It's literally helping to build the future of clean energy. And there's more. We've got chemical oxygen iodine lasers, or coils, that are powerful enough for industrial welding and could maybe even be used to clear dangerous space junk from orbit. And there are new fire extinguishers that use an iodine compound, which is so much better for the environment than the old ozone-depleting chemicals. So let's bring it all together. We tend to think of iodine as just, that simple antiseptic or something added to table salt, but what we've seen is that it is so much more. It's a global lifesaver, it's the unseen technologist powering our digital lives, it's a silent protector in the harshest conditions, and it's a key ingredient in building the world of tomorrow. It really makes you wonder, doesn't it? If iodine has this many secrets, what other common elements on the periodic table have these incredible stories just waiting to be told? What else are we overlooking right under our noses?